welcome everybody to this morning session of the principles of electrification for underground distribution networks. Before we start, I just quickly want to introduce our panelists to you, or the presenters actually. I'm going to give over to Petrus, and then Petrus, you can maybe hand over to Sam to just quickly introduce yourselves to our attendees.
Okay, thanks, Louan. Okay, my name is Petrus Keswa. I'm a design engineer here at Matleng Energy. So basically, my core expertise are in the field around electrification designs. So I'll just give over to Sam now just to go further on his introduction.
Thank you, Petrus. My name is Sam Mohlala. I'm also a design engineer for Pendo Energy Solutions. I've started my career here at Pendo, so I have 4 years experience in electrification networks. So today we'll briefly share our expertise with you guys with underground network distribution. Over to you, Louan.
Great, thank you, Sam and Petrus. I can ensure our attendees today, our guests, that you are in very good hands with these 2 competent engineers. So as I said today, we're going to go in a bit more detail into underground distribution networks. Just a little bit of background. Our previous session, we started off with the principles of electrification, and we first just gave an overview. Where do you start? Where do you take it from there? And then we did a session on overhead network designs, and thus bringing us today to underground distribution networks, which will be our last session on the principles of electrification, and also our last session for this year. But please remember to be on the lookout for any future courses on Pulse's website. And thanks once again for Pulse for giving us the opportunity. Petrus, I'm going to hand over to you. Petrus is going to start the session and then directly hand over to Sam. And sit back, relax, make notes, and enjoy the session. Thank you very much. Petrus, over to you.
Okay, thanks a lot, Louan. With this being the final session, we sort of just mixed it a bit. So Sam is going to start with the first portion of the presentation, and then I'll do the last section of the presentation. So Sam, if you can just prepare your presentation, and then you can start, and then I'll start from there once you've done your portion as well.
This is an underground electrification design. So we'll be focusing specifically on underground electrification. So this is just a recap. If you remember the first session, we sort of took you guys through these 3 phases. Here we are assuming that the land was available and funding is concluded. So inception and concept viability on phase 1, which is now where you engage with the municipality and check if there's any availability of capacity and the project can be actually feasible to be started. And then design development and procurement and implementation. So this is where now you do your detailed design, BOQs and costing for your project and take it out on tender for construction. So phase 3, construct and administration and close up. This is the construction phase where now you mostly doing site inspections and managing the contract and engaging with the municipality and successfully doing commissioning and handing over the project. And then now on underground electrification design. So I'm just going to take you through a few pointers. So application of underground electrification network. So it's mostly in urban areas, middle to high market segment, area with high load density. So this is where we use mostly underground network. Okay, on the benefits of underground electrification network, it is reliable. So as it is, it has few interruptions due to no external factors in close proximity to the cables. Everything is buried underground, so it's not vulnerable to lightnings, wind, and such things. Maintenance is easy. Capital cost underground is slightly more expensive than overhead. Life cycle, obviously, is a capital cost plus operational and maintenance cost. So if you combine all of this, the initial cost will be slightly expensive, but however, during the lifespan of the network, it might prove to be slightly less or in comparison with the overhead network. The underground network is aesthetically more pleasing than the overhead network. As you can see on the right, there's a picture there that will show you, the overhead network in a unpleasant sort of view there. So with underground network, you don't have to worry about such things. So it's not vulnerable to such external harsh weather conditions. So perceived public safety, there's minimal public hazard as cables are installed underground. So people feel more safe as they don't see the cables as like overhead networks. So they feel more safe and there's likely less hazards that can happen. And now on the shortcomings of underground electrification. Obviously, the capital cost is one of them. It's slightly expensive. Reliability, it takes longer to identify and fix faults. So you have to use specialized equipment to actually identify faults or cables underground, which one is connected to which mini-sub or RMU, etc. So cables cannot be overloaded, unlike overhead network. So the results in insulation failure can lead to increased faults. So if the insulation is not properly done or is damaged, that can lead to faults. And then this is the end of my presentation. I'm going to hand over to you, Petrus. Over to you, Petrus.
Thanks, Sam. As Sam has indicated, on that further was the second slide of the presentation. So I'll just go through the three phases on how we go about during the design for underground networks. So as part of the phase, we'll obviously interact with the supply authority just to understand their standards as well as their requirements for the particular development that we'll be busy with. With that as well, we'll also determine the load requirement. Basically, to determine the load requirement, we'll either if the supply authority gives us their standards and then they'll provide us with their ADMD, and then we'll calculate the load requirement for the development. In instances where it's a private development, and then they will use the SAN standards to determine the ADMD from first principles, and then we'll end up determining the load requirement for the development. Then from there, once we know the load requirement, we'll look around the existing infrastructure. If there's anywhere that we can be able to get the capacity that we need for the development. And then from there, together with the town planners, we'll be provided with the development layout. And then from there, we can start with our prelim designs. And then from there, in terms of the MV, what we also do as well, like once the development layout has been finalized with all the other disciplines, then we'll proceed into the cable in terms of the indoor or outdoor equipment. Mostly we'll use, if there are mini subs, we'll obviously use mini subs, and then we just have to obviously check from the source, the fault levels ratings, to make sure that whichever equipment that we're using on the development properly specified with the correct fault levels. And then that actually also goes for the mini subs. And then we'll proceed into the cable sizing on your backbone MV network. If it's a supply authority, they normally have the standard cable sizes that they use. And then most supply authorities have adopted XLPE cabling as their preferred cable, but there are still some supply authorities which still use the paper insulated lead covered cable. Once you know like your MV cable, the size of the MV cable that you be using, we'll obviously now look at the cable derating factors. we'll obviously look at the depth at which we'll be installing the cable, if it will be going through sleeves, or if we have multiple cables which are going through a trench. And then in all of this as well, we also guided by the supply authority in terms of their preferences, where they'll want to have the MV cable installed. Normally, the MV cables are installed at a depth of 1 meter below the final ground level. Then from there, we'll then look at the protective requirements in terms of the MV switch gear. Obviously in your mini sub as well on your RMUs, we'll look at the switch gear requirements which are there, either being breakers if we're supplying like maybe a commercial customer, or isolators if it's just within a ring. And then as well, what we also look at is it's in terms of the earthing and bonding requirements for the equipment. Obviously, all the equipment must be properly earthed to ensure equipment as well as personnel safety. And then in terms of the cabling, the earthing, like most supply authorities predominantly use the cable armoring as for earthing. This is primarily due to the challenges that supply authorities encounter if they were to use a separate earthing conductor. That conductor is normally stolen. So like supply authorities now usually use like the armoring of the cable as the earthing. Then yeah, this is just a typical layout of our MV network. As you can see here, like this is actually one of our developments that we did around Johannesburg. So this was a upmarket residential estate. I think the total number of units there was about 450 or so. And then we obviously have mini subs, and then from the mini subs we have like the MV cable. So in here in this development, the substation was just around this on the western side of the development. Then we installed feeder cables from the substation, 2 cables, and then those 2 cables were in a ring, so that we have redundancy like within this network. Then obviously we place the mini sub strategically so that we can provide the required load to all those single stands. And then, so that's essentially how we go about in designing the MV network. This is just an indication of pictures that we took in one of the projects. As you can see, the guys here were busy installing the MV cable. As on the picture, you can obviously see the depth of the trench, but the trench is 1 meter deep. And as I've indicated on the derating factors, the cabling, it needs to be properly spaced so that you can also try not to derate the cables. And then on this picture, it's just a picture of a mini sub in one of our developments as well. And then this picture indicates a picture of an RMU also in one of the developments as well. So on the mini subs as well as on the RMU as well, we'll have this equipment has to be at. This actually ensures that both the equipment as well here in the case of the general public as well, that they are protected in case of a fault or in case of like equipment failure also. And then if we now proceed to the LV design, that's also on the cable sizing. Supply authorities here mostly use PVC as the main LV feeders, but some supply authorities do use XLPE. Also on your LV design, you also have to take into consideration the cable derating factors. Then like LV cables are normally installed at a depth of like 700 millimeters below your final ground level. And then if there are road crossings, obviously you'll put in sleeves in there. And then mostly with LV, in the LV designs, because on a mini sub, you'll probably have about like 4 or 5 LV feeders coming from your LV board on the mini subs. So we also have to consider the rating because of the cables now are closely spaced to each other. And then as well here on the equipment sizing, we also need to, we also consider the fault level rating of the equipment that we're using. We also look the equipment that we essentially use here. It's ground mounted kiosk, as well as like miniature circuit breakers, which are installed on the kiosks. And then like further to that, the protection requirements at the mini sub on the LV board. Most supply authorities have now are more using molded case circuit breakers. But there are still some supply authorities which still have prefer to use fuses on their LV boards. As well, in terms of earthing and bonding requirements, in terms of the LV cables, so like on the LV side of your transformer, the neutral as well as the cable armoring, it's combined. That's the TNCS system. This ensures that like your fault level ratings are minimized on your LV network. And then we also do like the equipment as well in terms of the ground mounted kiosk. If they are obviously still structures, we also ensure that they are properly bonded. And then in terms of street lighting, with underground networks, for your street lighting network, you need like a separate cable there now as well to be able to supply your street lighting. Then in terms of the control of that, it's in most supply authorities have like a street light control panel within the mini subs. But other supply authorities have like an outdoor setup where they do their street light control. Then obviously with the luminaires, it's also like we got it here by the supply authorities to use LEDs, but there are still some supply authorities which are using the old HPS. But in terms of energy efficiencies and all of that, like most supply authorities are leaning more towards LED technology. And then with the metering, the meters are obviously housed within the kiosk. And then the preferred metering technology which is used is the split metering. Okay, and then this now is just a typical layout of the LV network. And then on this LV network is still the same similar development that we did here in Johannesburg. So as you can see, like just show this from a mini sub, we have a mini sub here, and then from there we'll have different feeder cables supplying this group of houses in here. Also another feeder cable supplying a group of houses in here. Then in here, you'll have a kiosk. From that kiosk, that's where now you'll have your service connections, which will now be supplying the end consumer. And then this is just typical pictures like how a kiosk looks. So this one here is just a kiosk on this side. We did not show you like the ones with the meters as well inside. So this is just like the feeder cable coming in there, and then just on the other side of this, it's where your meters are normally installed. So for this particular supply authority, in order to sort of minimize non-technical losses on the system, they put in a whole lot of investments into these kiosks, which are referred to as protective structures. So these kiosks are not just easily accessible. There are special keys that you need in order to be able to access and open this kiosk. So that's just the internal layout, and then this is just like the exterior of the kiosk. Then as well as this side, we're showing from one of our developments as well. So this is just like an isolation point. So what we normally do from the kiosk, because like only the supply authority has access to this kiosk. And then from here, we install the service connection cable from here to come to the customer isolation point. Okay, and then in terms of phase 3 of the design process, that's when now we are in construction in terms of contract administration as well as inspection. So once the design has been completed, all the approvals are in place, and then now we can go into on-site, whereby like contract administration, that's where like the contractor does the actual construction, and as well as the appointed engineer, and then you just have to make sure that like the work is carried out as per approvals as well as per the specification of the supply authority. Then we also do the financial control during that stage, and then for equipment as well, we need to do factory acceptance testing this is carried out at the facilities of the manufacturers to make sure that like the equipment prior delivery to site is manufactured as per specification as requirements of the supply authority. Then from there, once the equipment is on site, there will be commissioning as well as testing. And then as part of closeout, and then we'll prepare as-built drawings as well as closeout report. Okay, this is just one of the pictures in one of the projects as well, where we, in here, like it's just like a mini sub. So this is the MV compartment of the mini sub. This was just prior commissioning and testing. So this is the MV compartment, as well as the guys on site were just busy with the LV feeders on the LV board of the mini sub. Then once all of this is done, the commissioning has been done, all the checks have been done, and then the supply authority will then now come to site in order to be able to energize the network. As you can see here, safety is of paramount importance. The switching personnel are wearing all the necessary personal protective equipment. Okay, I think that should conclude our presentation for today. We're just showing all like sort of like our experiences around underground electrification design. So Louan, I'll hand back over to you now.
Great, thank you very much, Petrus, and thank you, Sam, for a wonderful overview on this topic. We're going to do a few questions and answers. So the first question that we have, Petrus, and I'm going to ask you to maybe answer this for us, is what are the main disadvantages of underground reticulation?
Okay, thanks, Louan. Okay, the main disadvantage of an underground reticulation is the capital costs, the initial capital cost associated with installing the infrastructure. And then this is mainly because if you compare it with overhead networks, your street lighting, you actually need like a separate cable to be able to supply your street lights, and then that now results in the network being more expensive. Also, as I think Sam indicated on the first part of the presentation, in terms of reliability. So with underground networks, it just takes longer to be able to identify and fix cable faults in your network. So you also need specialized equipment as well to be able to identify those faults.
Great, thank you very much, Petrus. Much appreciated. Sam, maybe I'll give you the next question to answer, which is, what is the best approach in getting power capacity from a utility company for the development area that you will be doing your design?
Thank you, Louan. The best way is to actually start engaging with the supply authority and analyze the network that you have around your development piece to see if there's any capacity or existing electrical infrastructure that you can actually tap into if there is any spare capacity. So you have to start that phase first, and then if there is no capacity, then you can look at other alternatives of getting supply elsewhere in the near area of that development.
Great, thank you very much, Sam. So yeah, so communication is key there. So best is to physically meet somebody in person, have a few discussions before you just fill in the paperwork and start your process. So communication is very key there. Thank you very much, Sam. Our next question, Petrus, what design packages do you use?
Okay, thanks, Louan. So what we essentially use here in our offices, we use MicroStation. That's for the essential drafting, like of the designs that we use, our drawing office use. And then in terms of the simulations of our design, we use Ratik Master. And then with Ratik Master, it's actually packaged in with Power Office, which just makes it the whole process of the design to be automated as well, to be able to do the simulations.
Great, thank you very much for that, Petrus. Maybe Petrus, if you can stick to you, what's the concepts of earthing in cable networks?
Okay, as we've indicated on the presentation, so like on the LV network, it is the TNCS system which is being used on the LV feeders. So what that essentially means is like on the secondary side of your transformer, the neutral as well as the earth, the protective earth is combined. And then when it comes to a kiosk on the customer side, and then like they are separated. So on the customer side, the neutral as well as the earth is separated. But then on the street lighting network, underground networks, it's just the TNS system, whereby like still on the transformer side, like the neutral as well as the earth, they are separated for the street light networks.
Great, thank you very much, Petrus. Sam, if I can ask you to maybe answer our next question, which is servitudes and environmental impact assessments. Maybe just to elaborate a little bit more on that.
Okay, obviously with the underground network, you have to take into consideration servitudes. So you have to also be guided by the GRA road types and servitude allowance. So GRA will give you a specific, let's say, meters of servitude for your cables. And anything beyond that, you'll have to speak to the developer to actually register a servitude for your cables or mini substations, etc. And also environmental, you have to also assess if it's an existing area where your cable routes will run. Is there any pavement that you have to remove and reinstate after? So that will also have some cost implications. And also other services might also be there. So you have to also liaise with your wayleave application service providers and see if there's any services that are running there, and then you can coordinate that. Thank you, Louan.
Thank you very much, Sam. And then I'm going to combine two questions because the answer is more or less the same for them. The first question is, what standard is best used for estimating energy requirements for a multi-story building complex? And then we have another question that's also got to do with the energy, and it says, which SANS standard do we use to determine hospital load estimates? And so we can carry on this commercial and all of those. So there's a standard called SANS 204, which is the energy efficiency standard. And in that standard, it's more or less explained what's the requirement or the maximum amount of load that you can actually apply to these various types of buildings. So you should find your answer there. What I do know is for office blocks, for instance, that you need to work or try not to exceed 85 watts per square meter. So that's just an example of an office block. So you need to go and have a look in the SANS 204 for your other answers. Then Petrus, if I can ask you, brings us to our last question for the day. Are there preferred cable sizes to be used for 400 volt level, especially when dealing with Eskom distribution networks?
Okay, thanks, Louan. ESCOM distribution, they are split into different regions. So they will advise like what their preferences are. It depends per region. Like for instance, we're doing a project here in just north of Johannesburg. So that particular ESCOM region, which is guided by its network engineering and design, as well as their customer network center, they prefer cables. But we also have like another project like in Cape Town, whereby aluminum cables on the LV side. So we just have to check with the specific ESCOM region, and then once communication has been open with that particular region, you'll definitely know exactly what cables do they need on their network.
Great, thank you very much, Petrus, and yeah, thank you to all our attendees or our guests that joined into the session today. And if anybody might watch this webinar afterwards, thanks for watching it. I hope you enjoyed the session, enjoyed the Q&A, and please be on the lookout for any further courses that might come out maybe next year. Keep looking on Pulse, on the website for Pulse. And once again, thanks for Pulse for allowing us to have this webinar. And thank you to Petrus and Sam for your time invested in this webinar.